take the help of pooled resources and environments for the hosting application. Supposing if it is not available, now it can take the help of the pooled resources available, something we saw in the grid computing or something like that. And the application utilizes the services, and these application utilizes the services available from other nodes or other systems also. And the cloud computing, again a similar thing like your web computing. Here the refers to the computing using a collection of services available over the internet. So internet should be there, and the internet provides different services, right? So it's a collection of services through which the cloud computing can be done, and this delivers computational functionality on the infrastructure of a service provider for connected systems and enabling distributed grid and utility computing. So we can say it's a combination of all these things, right? Something like there are the connected systems are available, and the distributed environment is possible because everything is connected to the internet. Grid computing is available again because everything can be called as a pooled system, and the utility computing is there. Supposing we want to use this particular cloud computing for one particular application, then we can call it as a utility computing. So it's a collection of all the above. XaaS, again, it's a software architectural concept that enables deployment and development of applications and offering services using web and an SOA, right? So this is what already we have seen, right? So there is an architectural concept, right? There's a software architectural concept that enables deployment and development of applications. Whenever I am going to use a different application, right, so I need some sort of key performance indicators, right? Supposing for example, we will take Microsoft Office, right? The Microsoft Office can be installed in your own system. That is actually one way of doing it. You have to purchase the Microsoft Office and you are going to install it in the other things. Supposing if the usage is very minimum, instead of purchasing the Microsoft Office, what you can do is you can take a hire, right? Something like for a period of service for a period, right? Using the Office 365. So in that case, all the data will be available, all the services will be available in the internet, and you will be allowed to use the service for a predefined time for which you have taken the permission, right? So what is going to be the comparison between these two things? So whether my application should run in my own system or if it can run in the internet. So there should be some performance indications should be there, right? So this is the key performance indices or indicators, and it refers to the set of values, and this usually consisting of one or more raw monitored value including minimum, average and maximum specifying the scale, right? Say for example, what is the minimum time of computation when it is used in your system, and supposing if it is used in the internet as a cloud service, so what is the minimum time of computation, what is the maximum time of computation, what is the maximum memory usage, and what is the average time of computation, average memory use, what is the energy consumed, and so some other parameters, right? So these are all some of the parameters which can be taken as the key performance indicators, and this service is expected to be fast, reliable and secure. So mostly there are three main things are there. One is fast, right? So it should be very fast, it should be giving the quick response, then it should be reliable, right? So all the time I should be having the access to the service, and it should be secure. Supposing I want to put some data for some computation, I am putting my own data into the web servers or whatever it is, and the data should be secured, right? So all these things should be guaranteed by this KPI. And the resilient computing refers to the ability of offering or maintaining the accepted QoS and the KPIs, right? Say for example, resilient in the sense normal English, right? What is resilient? After a problem, how my system come back to its normalcy, that is actually called as how fast my system can come back to its normalcy, that is actually called as resilient computing, normally resilient, right? In the case of resilient computing, what happens in the presence of an identified challenge, right? So there are some problems in the process, and after that problem, how my system can come back to its normalcy, right? That is actually called as resilient computing. So we will see the definition. In presence of the identified challenges, defined an appropriate resilient metrics and protecting the service. So the KPIs or quality of service should not get affected even after a identified challenge. That is actually called as the resilient computing. An elasticity denotes that an application can deploy local as well as remote. So elasticity means you can stretch or compress. In a similar way, two systems can be placed together, or it can be placed in a distance apart. In both the cases, the computational speed should not get affected, right? The throughput should not be affected. So that is actually called as elasticity. So what we can do is the system should be local, or it can be remote applications or remote services will be there. In both the cases, the KPI, that is the performance indicator, should be the same. And once I have used a system, we should be able to release them after the application usage. Supposing I am using a system, and once my usage is over, I should be able to release my system for further users. And the user incurs the cost as per the usage and KPIs. So based on the usage and based on the KPIs, say for example, supposing I am using a net connection, but at a slower speed means I will be paying some minimum amount. If I need a faster internet, so in that case I need to pay the maximum amount. So based on the KPI and usage, I will be paying some amount for this. And the cloud computing platform. What is generally cloud? Cloud is actually the internet cloud, right? That is actually servers and services available over the internet along with the clients. Clients will be available at some other locations, right? So there is a network which we can call it as an internet, is connecting all these things. And this user application and services with no boundaries and no walls. So when we have these two things, any user can run any application, right? There is no boundary or no walls, right? Because I will be sitting in one place and my server will be sitting in another place, and I should be able to use it because of the connection that is established using the internet, right? And what is cloud computing? Again, we have already seen this. It's a collection of services available over the internet, right? And it delivers the computational functionality that should be okay. That deploys infrastructure of a cloud service provider. So the cloud service provider will be providing some infrastructure, and that is deployed for our application. And it deploys computing infrastructure on a utility or grid computing or web services, right? So this computing infrastructure may be a single system. It comes something like utility computing, or it can be a grid computing, or it's a collection of web services, right? So there are plenty of web services available here, something like Amazon or everything. So it's a collection of all these things. And a computing environment that includes network, system, grid of computers or servers, and data centers. So a computing environment will be including a network, right? That is actually the internet that is connecting some system, or a single system, or it's a grid of computing systems or servers, and it should be also have some data centers where the data can be stored. The cloud platform services. So in this case, the infrastructure for large data storage of the devices, right? So I am going to have a large quantity of data. So in that case, I should be able to save my data in a proper place, and it consists of RFIDs, the industrial plant machines where my data is generated. Automobile is again a source of data generation, and there are some device networks, right? So it's a collection of all these things. It's a collection of infrastructure of all these things. And what are the computing capabilities? So there should be some analytics. There should be some software for analyzing, say the predefined KPIs, right? And IDE stands for Integrated Development Environment, through which we can write the program or execute the program. And there should be a sort of collaborative computing. Again, we have discussed it. The computation should not be done in a single place. It should be in a distributed way. And the data storage should also be shared, right? All the data need not be stored in a single place. The data store has to be shared. And what are the usage of this cloud platform? The first thing is for connecting devices, connecting data, and connecting APIs, right? So whenever I am going to have a cloud platform, I have more number of devices are connected together because of the internet, and the data can be shared. So this data is connected or shared between different nodes or different computers. And the API, supposing I have a library function, and this function can also be shared with the different systems that is available in the cloud platform. And connecting applications and services, connecting persons and connecting enterprises. It is useful for connecting different applications, services, persons and enterprises. Of course, no, it's nothing. And connecting businesses, we can connect businesses, and connecting XaaS. What is a virtual environment? A cloud storage and computing environment is actually called as a virtualized environment. Offers a running environment made to appear as one to all applications and services, but in fact physically two or many running environments and platforms may present. This is what virtualized environment. We will assume that my data and the system is running at a single point, right, at a single system. But what happens in the actual, the data is shared between the data as well as all my programs or APIs or functions, whatever it is shared between many number of systems, and everything is running individually. That is actually called as a virtualized environment. What is the characteristics of a virtualized environment? So it enables applications and services to execute in an independent execution environment, right? Heterogeneous computing environment. So I have different applications and that will be running in different environments. Say for example, I have written a program in the Windows platform, right? I will be writing a program in Linux platform or Ubuntu. I have, say for example, there are so many variations are there. Ubuntu is there, Kubuntu is there, so there are different executions, or Mac OS is there. So based on different environment, the execution is taking place at a heterogeneous, right, computing environment, and each one of them stores and executes in isolation, right? Everything is physically separated but logically connected, we can say, and each of everyone will store the data and executes the data on the same platform, though in fact it may actually execute and access to a different set of data centers or servers and distributed services and computing systems. So we will assume that it is done in the single platform at a single system, but actual cases it will be executed or access to a set of data servers, different data servers, data centers and distributed services and computing systems. And the virtualization of storage, a similar thing, right? We will assume there is a single storage, but the storage is distributed over the multiple systems, right? So means user application services access physical storage using abstract database interface or file system, or a logical drive or disk drive, though in fact storage may be accessible using multiple interfaces or servers, right? And